Next, we're going to talk about how to write the equation of a hyperbola. Okay, how to write the equation. And to do this, we're first going to look at our graphs and our charts on kind of the anatomy of a hyperbola. So, right here. So here's my graphs. Notice they're using a lot of the same notation. We're using vertex, covertex, and focus, and we use A, B, and C, just like we did with the ellipses. We use horizontal and vertical, and just like with the ellipses, my vertex and focus are in the X spot when it's horizontal, and they're in the Y spot when it's vertical, and of course covertex is always opposite. A difference is that little box, because notice the covertex isn't actually on the hyperbola. It's just at the top of that little imaginary box. Well, that box gives me, see those diagonals coming through the box? Those give me my asymptotes. See the word asymptote there. Okay, we've studied those. It's a line that my graph gets closer and closer to, but never actually touches. So that's the purpose of my covertex. There's those two graphs. If I come down here, it says my equation. Well, notice my equation looks almost just like the equation of my ellipses. The only difference is instead of using the plus sign, we're using a minus sign. Okay? Now, another difference is that with the ellipse, the A, I can always tell the A from the B because the A is the larger number. With hyperbolas, the A is not necessarily larger than the B, but I can still distinguish it because the A is always going to be first. Okay, whereas with the ellipses, I could switch the terms around because it was addition. Since hyperbolas use subtraction, I can't just switch the terms around. That changes things. For instance, 3 plus 2 is the same thing as 2 plus 3, but 3 minus 2 is not the same thing as 2 minus 3. Okay, so with subtraction, order does matter. So my A is always going to be the denominator of the first term, B is going to be the denominator of the second term, and I can determine whether it's vertical or horizontal by which variable comes first. If the X comes first, it's horizontal. If the Y comes first, it's vertical. Vertices, the foci, and the covertices are going to look pretty much the same. The only difference is they're adding this little thing called the asymptotes. Well, the asymptotes are plus or minus B over A times X. Well, B over A gives you the slope of the line times X. Okay, so we're adding that little thing there. Now, for our purposes right now, what we're trying to find is the equation. So for the equation right now, all I need is A and B. So let's look at a question. It says, all right, write an equation in standard form for each hyperbola. Well, I'm looking at this and I see, okay, well, if I go back to my graphs, I see it's a horizontal one. So horizontal is x squared over a squared minus y squared over b squared equals 1. So okay, so we have our equation standard form. We said it was x squared over a squared minus y squared over b squared plus, oh, not plus, sorry, equals 1. Okay, so I need to figure out, well, what is my A and what is my B? Well, if I'm going to look very carefully, I see that my little hash marks are going by 2 because this one right here is 2 because this one right here is 4, it has a 4 on it. So we're going by 2's. Well, my vertex, the point here and here, well, I see if I go 2, 4, 6, it's halfway in between 4 and 6. So my A, halfway between 4 and 6, has to be 5. Whereas my covertex, which would be here and here, would be 2, 4. It's halfway between 2 and 4, so the B has to be 3. It's halfway between 2 and 4. So on my equation, I have x squared over, well, 5 squared minus y squared over 3 squared equals 1, which is x squared over 25 minus y squared over 9. And that's my equation for hyperbola for this problem.